All right, let's go ahead and get started. Hello, everyone. Thank you for coming out to our industry panel event today. This is AI UCI's presenting the cutting edge of AI. Today, we're going to be looking into some of the developments that really happen in this very rapidly evolving field of research. And as we all are interested in AI, we want to see what's really happening at the farthest boundaries, and we're like the very tip of the industry, and see how maybe that can affect our understanding of the field. So without further ado, I want to introduce our faculty mentor and UCI professor, Dr. Stephan Mandt, to step up and say a few items about the significance of AI research, to introduce the panel and our panelists in general. So with that, I'll hand it off to him.
Right. Yeah, thank you, Aditesh. Thanks everyone here for inviting me. It's always a great pleasure to be part of this. So let me not waste too much time on giving a brief introduction of the significance of AI. As you all probably know very well, right? AI is basically everywhere in our daily lives, right? Ranging from business to, to health, to our everyday personal experiences. It's certainly part of the web, right? From the very beginning. We encounter AI in our spam filters. Nowadays, when you deal with machine translation, the first thing that you might just try is just Google and try to translate one sentence into another language. AI is being used in order to tag your friends on your phones or on social media. Another big progress in AI recently was sort of like a big milestone in which, for the first time, the machine was actually capable of beating the best player in the game of Go, right? That was a big milestone brought forward by DeepMind, and you could all watch it on television. Go, by the way, is considered to be much more difficult than chess. And for that reason, that was actually considered a big breakthrough. Similarly, AI algorithms are very good also at playing other kinds of games, as you can see here. But AI is also present in much kind of simpler setups without even us realizing it on a daily basis, right? Machine learning is being certainly used for Netflix recommendations. So basically, when you click on movies, AI implicitly learns your preferences and ranks movies according to the likelihood at which you'll enjoy these particular movies. It's also part in speech recognition, right? And other intelligent devices such as, Amazon's devices, for example. And finally, there's of course robotics that's driven in part by AI. In particular, self-driving cars nowadays use particular computer vision technologies to quite a significant extent. Broadly speaking, we like to think of machine learning as part within AI. So AI is the bigger term, and then machine learning is probably the most exciting part of AI nowadays, which is that part of AI that learns from data. And in general, I like to think of machine learning as being split further into three big areas. There's supervised learning, in which an algorithm learns explicitly from examples. Basically, given a certain data point and a certain associated classification, we want to teach the machine learning algorithm to exactly do what we would do as humans when we see particular data, right? Does this medical image show a cancer cell, or is it just a normal cell? Then there's unsupervised learning, which is basically a slightly more independent task of machine learning, right? You observe a lot of data, but the data does not necessarily have labels. And so basically you're asking your algorithm to essentially find interesting structure for you, right? That you as a human would also find interesting. And that sometimes allows you to, for example, solve needle in the haystack kind of problems. Finally, there's reinforcement learning, which is the closest to, general intelligence, if you want, right? It's really about an autonomous agent deployed in the world and purely learning from passive feedback and reward signals that the agent extracts from the environment. So think of the Go playing game, for example. I don't know, my presentation is frozen. Okay, yeah, just very quickly. So at UCI, we have actually a pretty large faculty doing machine learning research, ranging from, I would say, you can actually cluster us according to different criteria. So in total, there's a lot of faculty doing AI. Some of them focus more on theoretical aspects or reasoning, kind of connections to logic. Others are primarily interested in text and natural language. We have a lot of experts in computational biology. Some people primarily working on computer vision problems, others RL, and also others on the connection to systems. We have many initiatives at UCI that kind of celebrate AI, and that, many centers that center around AI. And here's just like a collection of subsets. We have the Center for Bioinformatics. We have the PhD school by the Hasso-Plattner Institute focusing on AI. And we have, for example, the UCI Data Initiative. Without losing too much time, let's maybe get to the interesting part and introduce the panel. So it's my great pleasure to introduce 3 panelists who all have demonstrated significant expertise in the field of artificial intelligence, and in particular in its implementation, implementation in business relevant contexts. So first we have Ali Loghmani, who is the co-founder and CEO of Planner. Ali started coding when he was only 13 and sold his first app when he was 16, while he was having his first access at the age of 24. So absolutely no pressure for any student here on the call. At the moment, he's working on the future of data and ethical and practical ways to utilize AI to augment SMEs. We then have Mihail Eric, who is a senior machine learning scientist at Amazon Alexa AI. So Mihail is the founder of Pemberton Data Innovation, a machine learning consultancy focused on helping organizations build data-driven systems to solve the toughest business problems. He's also a founder of Confetti AI, the premier educational platform for practitioners learning the skills to succeed in their machine learning and data science careers. And last but not least, we have Somesh Mohapatra, who is a PhD student in the Department of Material Science and Engineering. Somesh is also pursuing an MBA at the MIT Sloan School of Management as part of the Leaders for the Global Operations Program. In his doctoral research in close collaboration with experimentalists at MIT, he focuses on designing biomacromolecules using interpretable machine learning and simulations. So I really look forward to that exciting panel discussion. And with that, I'll just hand it over back to Aditesh. Thank you.
Of course. So thank you for that wonderful introduction, Professor Mandt. And as we look to transition to the actual meat of the discussion, I would like to introduce one more member, Jimmy Liang, who's one of our mentors, webmaster, and officers within the AI UCI organization. He'll be fielding all the questions. And later, when we open it up to discussion from the audience, he'll be also taking your questions as well and posing them to the panelists. So with that, I'll hand it over to you, Jimmy.
Hello, everyone. Thank you, everyone, for coming. And I guess now I will begin some questions. I guess the first question is probably to Somesh. I hope I can pronounce your name correct. So basically, AI has had a significant impact in the medical field. How effective is AI at medical tasks when in the drug discovery when comparing to doctors?
That's a pretty interesting question, actually. When compared to doctors or experts, who I would rather refer to as let's say medicinal chemists or doctorates rather than clinicians, I would say AI is pretty effective in getting the leads correct. Because when you have an entire data set of proteins, let's say, and the very tenet of drug discovery is if there's a protein, you want a drug molecule that binds to it. It's like finding the exact fit into it. And sometimes it evades human intuition. But once the lead has been recognized, oh, there's one small benzene molecule and another nitrogen group, and the AI model or the drug discovery high throughput screening model identifies that, the next step is essentially to hand it over to an expert or a medicinal chemist and say, hey, based on your intuition and having seen so many molecules over the years, can you increase its efficiency? So AI is just effective in accelerating it, but not taking over entirely at this point. I hope that answers your question.
Yeah, that's a good answer. Yeah, we'll see what's going to happen in 10 years. Maybe, AI can be better than doctors. We'll see. So next question is to Mihail, hope I pronounce your name correct as well. So, so nowadays we are hearing of large language models like GPT-3, which transfer well to all kinds of different NLP tasks. So, with that said, what architectural approach do you think will dominate the industry 5 years into the future in the NLP field?
Yeah, I think that's a really good question. It's an important one because I think machine learning modeling has changed a lot, even in the last few years, but certainly, when it started getting popular again in the last 10 years, there have been very wild advances that have happened every few years, basically, where a new modeling architecture becomes the dominant way to do something, and then we adapt it for a lot of different use cases, and then a new modeling architecture becomes popular. And so I think it's fair to say that the stuff that's popular today will maybe still be around tomorrow, but it's almost guaranteed that new stuff will come out on the market that people are using, adapting. And so while large-scale language models and just large-scale models in general, I think are very dominant these days for a lot of different use cases, language definitely, but they're also being increasingly used in vision. I think there's a lot of opportunities still in adapting to non-supervised learning contexts. So I think supervised learning is one of the dominant de facto ways of doing machine learning tasks today. And it has been for the last decade. I'm particularly excited about what more there is to be done in unsupervised learning. So how can we go past needing to develop these very tailored labeled data sets for different tasks that we're working on and be able to just leverage this overabundance of unstructured data and unlabeled data that we have out in the world. I mean, if you just scrape the web, there's so much of it that isn't labeled. And yet we're not really, we're not even leveraging 1% of that. But I think that we're, gradually in the research community, we're developing techniques to try and address some of those shortcomings. I'm also particularly excited about multimodal learning. I think that thus far, a lot of techniques and advances have largely been focused on the single vertical, if you want to call it that, where we build NLP models for language, we build vision models for vision, we build these very hyper-specialized models depending on the domain that we're looking at. And I think we're just starting to see that actually the way forward is to try and combine signals from multiple different modalities. I think there's a lot of opportunity to just continue to push that forward. Recently OpenAI released their Clippy model, which started showing that what we can do when we combine just vision and language is just these two interesting places to intersect. I think we're going to see a lot more of that. And I hope that we do a lot more in that general realm, because I think that if we want to really push the next frontier of general intelligence and just broadly AI, we're going to need to cross over across domains.
Really interesting answer. Yeah, we'll see. It's going to be an interesting time for AI, at least. So next question is to Ali. So you are very passionate about scaling the AI in an ethical way. So why did the intersection of AI and education stands out to you? Why? And what are the things we should keep in mind, basically?
You want the long answer or the short answer?
Whoever you feel like it.
The long one.
All right. So, so a few years ago, when I quit my job to commit to this idea of augmenting subject matter experts, I didn't know a lot about ethics of AI. Right? I mean, you would talk to people who would say, "Hey, have you heard about what people at OpenAI are doing, or the new algorithms? We can create autonomous things. We can create autonomous financial advisors, autonomous doctors, autonomous fitness trainers, autonomous counselors, autonomous shrinks, and whatnot." And that idea was very hot, maybe, I don't know, 7-8 years ago. But then as I got into the grooves and trenches of validating a few hypotheses in different verticals, I realized that you cannot take people's jobs away. And no business can be built around autonomy. You have to make sure that the business that you're creating is sustainable, it creates jobs, and doesn't add to the anxiety that is prevalent in AI in general. So I remember I tried a few, I would say maybe a dozen verticals. Started with financial services, then got into, I remember back in 2015, late 2015, early 2016, when back then candidate Donald Trump and Senator Bernie Sanders were campaigning on economy and the idea of college debt. I thought maybe it would be a great idea if we could create a financial advisor to help students learn how to deal with their college debt. So first thing I did, we created a service to automatically answer financial services questions relevant to college debt. We tested it, it failed for various reasons. I don't want to get into the reasons why it failed, but then I took that idea and applied it to an adjacent vertical, somewhere in healthcare, not very adjacent, but the idea was to create an autonomous diabetes counselor. Diabetes is a serious problem. What if we could advise people how to manage their diabetes and maybe reverse it? Long story short, after failing in 12 verticals, I realized that what we are doing is essentially creating a subject matter expert to provide a contextual advice to the consumer, right? And as I shared with you, you cannot kill jobs. And that idea, trying to bring balance to that equation, I realized that, wait a second, what we're doing is actually augmenting subject matter experts, not replacing them. And the idea of providing contextual advice is essentially natural to what you do in education, right? In education, you have a coach, you have a subject matter expert, you have a professor, you have a teacher, you have a tutor who provides mentoring, teaching, or coaching to a student. And it felt so natural. And it was way before the pandemic that we started testing that and testing the idea with some VCs here in Silicon Valley and business owners and schools. I soon realized that schools were very anxious about communicating with startups before the pandemic because they did not want to try new things. AI was a big taboo to them. Believe me, I mean, in 2018, 2019, you would talk to schools here, even in Bay Area, in Cupertino. I'm sure you have been to Bay Area before, or if you have not, Cupertino is where Apple is, and it's sort of the center of Bay Area, if you ask people. And schools would not respond to my emails. They were afraid of AI. But once pandemic hit, everybody wanted to learn more about AI. And you would talk to teachers, yeah, I mean, we need AI, but we need it in a way that will not kill our jobs. We want to be able to communicate with students. And if you talk to students, how many of you are happy with watching MOOCs? Do you find them engaging? Do you find them entertaining? Do you start one and finish it to the end, or you just let it go and just you do your Facebook or your Insta or your TikTok? So there are multiple things that we wanted, issues that we wanted to resolve. I don't want to go on a tangent, but the underlying principle that we wanted to make sure that we do not violate was not killing jobs. And the only way to do that is to make sure that you recognize the ownership of data and you recognize the rights of the people who produce the data. Teachers and tutors and professors are in the center of it, and also students contribute to that as well. Now, augmentation will happen only if you realize that right and acknowledge it as a right. Otherwise, you can aggregate data, put it into a bag, give that back to a model from 30 years ago, not even GPT-3, And then in time, that machine would be able to figure it out, right? You know, put it on a cell phone like this. That machine would, for this cell phone would take maybe 10 years, but after 10 years, you can have the best AI ever that could teach you anything. I mean, take it with a bucket of salt, if you will. I'm just exaggerating, but just for the sake of the conversation, if you give it enough data, you would be able to model a space model. You would be able to crack the physics of a space model. Once you do that, then it's game over for any jobs. But if you build the castle or the cathedral with the principle that the bricks that we are using building this structure is owned by multiple people, we can augment the content contributors. I hope that helps.
Thank you. Yeah, good, really good answer. Yeah, I enjoy it a lot. I do agree with you in the ideas. So next question is probably pretty related, but to Somesh. So basically, we often hear about AI replacing jobs and entire industries. So what is your take on the future of the workplace with AI in the picture?
Oh, that's kind of pretty interesting. Like, let me take a slightly longer route to arrive at the answer or my thoughts, to be honest. I'm a huge fan of history in general. And I love to watch the gestation periods of different items in technology. One of the examples that I remember very clearly is 1903 and the Wright brothers flying the first airplane. Before the commercialization of airplane or aviation and passengers flying, it was already mid-1930s. Same happened with the internet. 1960s, ARPANET, and then like by 1990s, it was commercial, and you could get those. Like I remember from early childhood when I used to have this linking modem in my home, and we used to have a telephone, and like, and that sound would be like the modem broadband service. I'm pretty certain people of this generation, and like maybe more than half the people, won't even realize what I'm talking about. But that used to be the reality back then in 90s. And the same thing is what I see with AI. Sadly, when people see new tech like AI, they think about Moore's law, which is essentially like the miraculous doubling of power of microprocessors. And that's not how like AI or tech works. And as Mihail points out, it's like all of these things that like AI in today's world is developing, this is very, very specialized. This is very niche. And all that the system knows is to mimic the data that has been fed into it. And it's just the mean of the human behavior. Most of these systems have a Gaussian distribution or a multivariate Gaussian, if you think so, behind them. And they would just say, oh, this is the mean, and give them a completely novel situation. Like if I present a metastasized cancer to a doctor who is a radiologist, they would be like, oh, this is new. And they would be able to identify that like spot on, and they may write a paper and get it published. But if you give like the breast cancer model that was published, I believe, by Google last year, it was in collaboration with folks in UK. Nope, the AI model will not be able to figure that out. It's only a tool that is going to help doctors focus on more specific tasks. It is going to help screen a whole lot of things just to make it easy. And one of the things that is told very often that we have built models that kind of defeat the Turing test. It's one of my favorite examples going back to 50s when Alan Turing developed it. Wait, like when in 50s, we had models that were trying to question like everything that you say, which is very typically called root cause analysis. If I say, I'm having a good day, then the model would say, why are you having a good day? And it just goes on with a why or a what and things like that. And if I present to you a chatbot of today, you'd very easily say, hey, that's a chatbot. Please stop irritating me. Like more often than not, you would say that. And like if I'm chatting with like a financial system or a bank, we would know it. And that essentially means that all of these Turing tests and all of these special like jobs that require a whole lot of thinking cannot be replaced in the near future. And a lot of these development, interestingly, is happening in small pockets. Like as Ali points out at like the need of like edtech in schools in the pandemic, we can think about the warehouse automation. Boston Scientific having this nice looking like cheetah running around in the warehouses, or getting into spots which are too dangerous for humans to go in, let's say a power plant or a nuclear power plant. And that's where AI is actually doing things, but it's still very concentrated. Maybe 10 years down the line, maybe 20 years down the line, we would have systems that are better, less specialized than today. But I hope I'm proven wrong. I don't know if that is a great statement here, but artificial general intelligence is still very far from where we are today. And that essentially means that just instead of defeating a person on the other side of the wall, that they're actually talking to a human, this particular model, let's say in the context of, again, like a whole lot of my examples, I realize that they're in the medicine sector, but they should be like, let's say, a caretaker who is able to understand the emotions of the person they're providing care to, know like what their feelings are, communicate it to the family members, understand what their medical needs are, talk to the doctor, do the physical tasks, their physical dexterity, the social interaction and judgment, instead of just symbolic data processing. And I have a belief that it is far, far away in the future. But as we know, that the future of AI is the future of work. So we need to be very careful in what we are developing and how we are developing. So it's not a jobless future, to be honest, but it remains to be seen how it is going to be. I actually have a suggestion for you folks. This is one of the books that I'm reading currently, but if you are interested, The Work of the Future, it's by David Otter Mendel and Elizabeth Reynolds. It discusses this very thing around AI in great detail as to like how AI is going to change the workplace in the future. And it's like out, like, I think a couple of months ago, actually in Jan 22, a month ago. So yeah.
Thank you for the answer and the books. I'll definitely read it if I have time. So next question is to Ali. So basically, as the industry continues to evolve, what regulatory concern do you think we need to consider when incorporating data-hungry machine learning model in our society?
Well, that's a very convoluted question. I'm not sure if you heard about what's happening with Meta and the European Union and the issues they are having with GDPR, and also California is having its own CCPR around, and concerns, global concerns around data privacy. So let me just and by the way, I would love to learn the panelists and the students and other people's thoughts on this. The way I look at AI is that essentially it's like a calculator. It is a tool that we can use to get better in doing things, and it's just a tool. But the problem with this tool is that some people can use it in a way to deliver services at pricing that could make business for others difficult. So when you have a lot of money, when you raise a lot of money to, let's say, bring automation to a sector, you can deliver, let's say, a service at scale, then a lot of people who are already in that sector won't be able to compete with you, because they won't be able to match your price, and they did not have the, let's say, they don't have the muscle or the tools to raise as much money. And so there is a big issue with let's say monopolies and businesses going just growing without being checked. And AI can be, let's say, a fuel to that to this concept. So when you look at, let's say, in particular in education, one of the things that I keep reviewing is the idea of building the right set of shields for content contributors. For, let's say, now, Somesh believes that this may happen 10 years or 20 years from now. I don't know, I'm not sure about Mihail's thoughts on this, but I do believe that some services can be automated much faster than 10 years from now. Some services can be automated. Some services are automated now. Some services, I mean, I know that full-fledged coaching or full-fledged tutoring is something of an AGI thing, which can happen, which may never happen in our lifetime. But some services are happening very quickly. Now, to make sure that people are not deprived from their God-given right, which is the right of having a job, we need to put in place the policies that would recognize content ownership. Again, I'm going back to content ownership, and some of the things that I've been talking with friends about is the idea of maybe even taxing them. So it's a silly idea, but something that I've been thinking about. Can we say a machine can own content that is produced by human beings? Let's say the content that you put into a bag, and that content is being used by GPT-2, GPT-3, or Lambda, or some other services out there. These are not being rendered by, let's say, a simulation or Monte Carlo kind of a thing. These pieces of data are being collected from human beings, maybe through even clinical trials. Who owns these pieces of data from which a machine is learning intelligence? And this intelligence, who's going to use this intelligence? Is it going to be, let's say, a startup or a government or a company? And once that entity, whatever it is, uses this intelligence to render a service that is that cannot be matched by other contenders in the market, who is going to pay for the losses forced upon the other players in the market? And once people are forced out of their jobs, who is going to cut their universal basic income checks? So the ramifications of not putting the right checks and balances in content ownership are scary. And it's not just that, okay, some people will lose their jobs. They have to move to some other jobs that are, that would use more human skills and less repetition. I understand that. But the fact of the matter is that as AI progresses, some companies, some entities will be owning a lot of data. Now, the question that I'm raising here is, who owns this data? Let's say if you are exchanging your data for an ephemeral, short-lived reward, dopamine exchange, are you also giving up your right, your part of your future? Are you also giving up a slice of your job of the future? If you're not aware of this right now, but those who are aware, those of us who are actually thinking about this and working in this field, if we do not think about content ownership and data privacy across the board, I think it would be a failure. And we have to take this serious. It's not just all rosy. I understand that some people may disagree, but my focus is on scaling AI and bringing automation and fulfilling its promise of increasing GDP while augmenting jobs, and on top of that, creating new jobs. And now let me just finish my answer with this. Imagine if you can model the space of fitness. Imagine if you can model the space of healthcare, and imagine if you can model the space of culinary arts, right? I'm exaggerating, please be patient with me. Now new jobs can be created. And by the way, we are modeling these spaces through augmentation by recognizing people's rights to their data. Can I have now, can I use a service now to help me lose weight or gain weight by eating what I love to eat and eating the food that keeps me healthy. Now we have an opportunity to create even more data and create even more jobs. Now, this is a very simple example, but I hope that it conveys the idea behind it. Thank you.
Thank you. Really good answer. So I guess this is probably the last question for me for today. So to Mihail, so if we look at the media, there's always crazy examples of like AI taking over the world, you know, like Skynet or those kind of things. So in your opinion, how far away are we from an actual AGI or like the singularity, basically?
I guess I got the question that Somesh basically answered for me. But actually, before I even get into that answer, I just wanted to address one thing that Ali brought up. That was like a very good point. I think that these questions around ownership and data privacy and who owns the data are very fascinating ones, not only from a societal perspective. I think in research, there has been actually some work even trying to answer some of these questions around, there's work coming out of James Zhao's lab at Stanford, where he's actually trying to, you can try and, if you want to like assign value to data, right? If we go on this hypothesis that data is what powers all machine learning models and they power all AI in the future, then if you want to start getting toward maybe an equitable society, you can imagine trying to pay people for the data that they're, you know, offering up to these services like Facebook, like Google, et cetera. And you know, that starts to ask the question, like, how do you actually evaluate the value of a single data point? Like if I am doing one like on a Facebook post, how much money should I be getting paid for that, right? How much am I actually influencing the model that they end up using to then service other users? And so, you know, just maybe a general thing for the audience as well, and people may already know this, but James Zhao's lab is doing some really interesting work on like data valuation, basically, and you know, that kind of starts to answer some of these questions, or at least to try and answer some of them, if we want to get to like the root of what is the value of data, really, in a society that is very data driven. So that's one thing there. And then on the AGI point, I think it's interesting because when I was graduating high school, I think one of the first books that got me like really interested in AI and convinced me essentially that I wanted to study, you know, computer science and artificial intelligence in college was actually The Singularity is Near from Ray Kurzweil. And so that, you know, that I read through that book and was very convinced that like, hey, 2030, 2040, like this is going to happen. And I want to be a part of this wave. I want to make sure that I'm contributing to this future because he says it's inevitable. So we should believe it's inevitable. You know, there's a lot of compelling plots and graphs, and given how society was progressing, it seemed very clear that we were going to have largely sentient creatures and, you know, this exponential accelerated return on intelligence. And so that was, you know, the philosophy that I was going into college with. And then around that time, the film Her came out. I really love Her as a movie. I think it's a fantastic film. Again, the idea of like sentient artificial intelligence. But then when I started doing research in college, and you know, as I've been doing research, you start to see that the reality is a lot more difficult than that. It's a lot more complicated. It's not enough to just draw a plot where you have an exponential and say, oh, well, this is where the singularity happens, and this is where AGI becomes co-inhabits the world with us. I think that we are still struggling with a lot of very fundamental issues in AI today. I mean, I focus a lot on natural language as my area of expertise, and we are just, while we made a lot of great advances in the last like 5 to 10 years, there are just like very fundamental questions we still don't have good answers from a research perspective. I mean, they're really fundamentally research questions. And if researchers are even struggling with them, then it's very clear that, you know, that we have a long ways to go. I think that, you know, a few examples like question answering, doing multi-hop question answering is something that we still struggle with a lot. You know, you can do simple, give a question from a passage, extract some subset of the passage that is a response to the answer to the question. We can do that, but if you have to do multiple levels of reasoning, systems really struggle with that. Common sense, like how do we capture common sense? What does it mean to have common sense as a machine learning model? And how do we even codify that at all? I mean, how do we even pose that as a problem to a machine to try and learn common sense? We are really in the early innings of even trying to tackle some of these questions. And you see that because we don't even have the data to start to answer some of these questions, right? And so we're just starting to build out data sets. We're starting to have these conversations from a philosophical perspective. Like, what does it mean to have common sense? Like, I as a human being, if I have common sense, what does it mean to endow that ability to a machine? There's really, I would say there's a lot more questions than there are answers at this point. And I guess maybe the long-winded response is, if I was encouraged by the idea of AGI at the beginning, I'm certainly less encouraged that it's going to happen, in the next 20, 30 years for sure. Maybe in our lifetime, may never happen, and that's okay. I mean, I think that's okay. I don't think we have to achieve AGI to progress toward a society that's on the whole better because of the existence of AI, right? I think Ali talked a lot about that, and I do very much share that opinion. I think that we can find a way to be assistive in the kinds of technologies that we build through AI, rather than replacing people. Rather than that being the goal, we should just try and make sure that we are constantly, kind of filling each other's gaps, so to speak. Like, working in tandem, I think, is really where the biggest gains for society will come from. So I think it's a long way away, may never happen, but I don't think that should decrease our interest in the idea of AI as a technology for the future. I think
So yeah, really interesting answer. So I guess that's probably all the questions I prepared. So I guess I will, so if anyone else have any question they want to ask the panelists, I guess you can just raise your hand and I will let you unmute. Is that correct? Okay. Let me, yeah, I think can you unmute yourself, Etienne? And
yeah.
Okay.
Hi. Hi, Ali, Somesh, and Mihail. I want to ask a question. This question is kind of followed from a point Somesh mentioned. So Somesh mentioned that there was a model and it was not able to identify a data that's out of the distribution that it haven't seen in its distribution of the training data. I think the current academic society have some measure for and some techniques to solve that problem, right? So we have ensemble methods. We have, for example, Bayesian modeling for the if you're doing neural nets, but Bayesian neural networks are pretty unstable, but ensembles are working. So if assuming all the ensemble members have good enough prior and good enough inductive bias when we're designing the model, so that's still not enough, or yeah, that's kind of a question.
That's a pretty good question, and along with just to I take it as both a pros and cons the approach. So in terms of pros, definitely there are models, even other than ensembles, which I believe address to the key idea of the epistemic uncertainty. Like, if you go into the theory of uncertainty, the two major uncertainties would be epistemic and aleatoric. And yeah, it addresses the epistemic uncertainty. But what these don't do are essentially not focus on the very nature of the aleatoric uncertainty, which is essentially that the physical system is also random. That okay, tumors that look like what the model has seen might not be what exist as tumors all the time. There are also things such as Professor Mandt says about out of distribution detection or anomaly detection. It's a major thing, and anomalies. So there are approaches that you can do using support vector approaches or kernel tree estimation methods that can detect anomalies very easily. It's just things about all of the data as within one hypersphere, in an n-dimensional hypersphere, and then says that anything that lies outside that distribution or outside that sphere is an anomaly. So there are ways to do that, but it all boils down to the fact that how well the model can do it. And are we eliminating the need for people in that process?
I do it, you mean, yeah, predicting it, or?
we can totally predict, but like it's just about the confidence of prediction when it is like really out of distribution, and like where exactly you draw the line. For instance, like if you're detecting tumors in a cancer patients, or like just like regular screening, like when to like say that yes, we are very confident of the model. There's very recent work where actually this confidence intervals are being studied, and like people are being screened at different frequencies rather than like every single year. Regina Barzilai from MIT actually did some really good work on that, and it was out in iClear, I believe, or maybe NeurIPS. I'm forgetting this. These two are very close. NeurIPS presentations and iClear acceptances. So yeah, but yeah, like there's work where people are trying to do it. I won't say that it's not completely impossible for a model to do it, but still like out of distribution detection, or just to like go away from the uncertainty, it's tough. And when we are using like ensembles, even in ensembles or like Bayesian networks, we're getting a mean and a standard deviation. Like just the ensemble would give you a mean data point and a standard deviation. What if the variance is really high? Because when you are using like one experience of mine suggests that when you're trying to use, let's say, simpler models, not like neural networks or like MLPs, just like simpler models, and you try to augment data, then the variance is really high instead of, and the mean can be like really good, but the variance just increases and like goes away. So the mean does not mean anything at that point. And that is just based on how the model is trained, because it starts putting like more information into one single value. But as you change in terms of whether the cross validation or the hyperparameter ensemble keeps on changing, then all of those models, the mean predictions vary a whole lot along that, like let's say the ground truth value. And the possibility of an ensemble variance being trusted goes out of the way. But yeah, that's kind of like a long run of the answer. Happy to take this question. Like I have some like really deep thoughts on uncertainty, because I tend to work on that space, both from an hyperparameter ensembles approach and just a model architecture ensembles approach. And along with that, also just about the interpretable nature of it. If you're interested from an academic point, the interpretability around this can be like best found in a paper in 2017 NeurIPS. Anshul Kundaje working on axiomatic attribution, talking about sensitivity and implementation invariance in models. So yeah.
Can you repeat the name of that?
I will post the link of the paper. Don't worry about that.
Thank you so much.
No worries.
Okay, so I guess we'll probably go to the next question. David, can you just unmute yourself and ask the question? Thank you.
Hi. This question is for Mihail. Like you mentioned, a few years ago, I watched Her, which became my favorite movie, and that got me really, really interested in NLP. And I was just wondering, I do want to go to grad school to study that. However, from your experience and kind of what you know so far, do you see it as a field that has a lot left to explore, or are we kind of reaching the limits of what machines can do and what math or stats can possibly predict?
Oh, there are so many problems for you to work on. There are so many. I think you could do 5 PhDs and you wouldn't even start to scratch the surface, I think. Yeah, the short, really direct answer is I don't think you should be concerned about directions or whether or not there will be problems to work on. If the ultimate goal, if you consider that to be a goal, is to develop her levels of intelligence, then we are a long ways away from that. I think there are a host of different problems that we're just starting to scratch the surface. It may not be, statistical methods may not be enough, right? In the past, earlier versions of AI were a lot of them were based on symbolic methods. And then with the growth of data, we started to rely a lot on statistics, and that has become the trend of the last multiple decades. But, in a sense that there's a lot of potential that maybe that isn't even enough, right? And then maybe we have to find some synergy of the two, or bring back old methods. I think that there are way more questions than there are answers, legitimately, from so many different parts of natural language processing and understanding and just conversational systems. I mean, there's, if you've spoken to any like virtual assistants recently, they're not great. You know what I mean? They're not really that great. And this is not for lack of trying. There are a lot of smart people in very large teams that are working to try and improve these systems. And the fact that we're not there even close suggests that there's just a lot of opportunity. So my generally, I don't think you should be concerned about that. I think there's so many directions you can go. So if you're interested in that kind of work, then I think there's a place for you for sure.
Thank you.
Thank you very much. So
Can I
next
answer that question,
yeah.
Jimmy? So great. It's a great question. I would not go after creating something like her, but I would focus on domain-specific assistance, something very niche, something that for which we can acquire enough data. Now, acquire it ethically, but if you create a business and that business can accumulate and aggregate data and keep fueling that data back to your system in an ethical way, you have a chance of creating automation and creating and providing augmentation to your content creators and affordable service to your consumers. It has to be very domain specific.
Thank you.
Okay, so thank you very much. So next question is Abhishek. Sorry if I pronounced your name wrong. Can you unmute yourself?
No, yeah, no problem. So my name is Abhishek, and I'm a first-year student here at UCI. So I would first like to start off by thanking all the panelists. This was a wonderful discussion up till now. I thoroughly enjoyed. So my question is for Ali. So I recently read a book on AI called AI and the Future of Power, and the book talks, the book talks about, the author says that there are a lot of concerns regarding AI, and he presents a very scary version of the future. And he says that there needs to be a wake-up call in society towards the sheer power AI can have on our futures. So you mentioned some of these things in your talk as well, right? Like about how some companies are really growing powerful and almost have an unfair advantage. So I would like to ask you how do you see the general awareness of such concerns in the general public? And how much work do you think is required to create awareness, the right amount of awareness regarding AI? Thank you.
Thank you for the question. It's a great question. Unfortunately, I've not read that book, AI and Future of Power, if that's the name. That's the name, right?
Yes, and the author is Rajiv Malhotra.
All right, remember to look it up. But I can share about what I've read in AI in 2041 by Kai-Fu Lee and another author. And I remember, just running my daily runs about 5-6 months ago, and I would just listen to the Audible. The picture that majority of people paint is sort of cautionary. Although it may be bleak, but we all know we're not going to. Hopefully, we will not let it happen. And there are ways to avoid it. And if we just give away our data, our content to a handful of companies, the problem is that we will be left with some super mega wealthy entities and a lot of people who won't be able to even think about closing the gap ever, not in thousands of years. So that idea, I don't want to, imagine my kid growing up in such an economy, such a society, and if you look at, let's say, the thing that I remember reading from 2041 and listening to 2041 was the idea of white collar jobs going away and people have to focus on providing very high level services to people, and repetition will be replaced by machines. Yes, this could happen, but if you recognize content ownership, if you recognize the idea of data ownership, if my data is being used by a machine and that machine is making money, will I be can I earn some money, a fraction of the benefit that is being produced by that big machine? If so, think of it as a royalty model. Authors right now and actors as of this moment get paid every time their movie is being served through Netflix or Hulu or other streaming services, and authors are paid whenever you buy their books. Why shouldn't we create such a system for content creators? I'm not talking about influencers on Instagram or TikTok. I'm talking about every one of us who are liking a post, leaving a comment somewhere, writing a blog, or creating a data entry for a data set owned by some entity. If your content is being recognized and your share, the gradients that are being trained and learned by a network is recognized, then every time a business makes money off of your data, you would be entitled to, I don't know, maybe a fraction of a few cents every 1,000 times that service is being rendered. But don't get me wrong, in time, that money accumulates to some meaningful dollar, to something that you can actually start living off. Instead of relying on UBI, you're incentivized now to create data, create more data for automation. And when you do that, you'd be able to make money. Again, it's not Instagram, it's not TikTok, it's just creating new data, novel data. And just imagine, I know that the idea of her came up, personal assistance came up by Mihail. What do you think about the voice actors? Let's say I create a chatbot and that chatbot can, utter sentences. But what if I bring in, let's say, a good voice actor who could mimic, I don't know, maybe Albert Einstein's voice? That person is producing content, and every time her content, her voice, or his voice, his voice is being rendered, he would be entitled to that transaction. So we can create an economy with new jobs if we acknowledge people's right to the data that they generate. And I think that future is going to be a great future, which I want to be part of. I want, if let's say 10 years from now, or 20 years or 30 years from now, I'm not sure how far into the future this will happen. If I could spend $500 of money, $500 of money now in order to buy services to learn how to manage my finances, how to be a better parent, how to enjoy my travels, how to cook food or things like that from best services, I would love to do that. It would make me a better person. At the same time, the companies that are producing such services, rendering such services, will be making money. So it would be a great future. I don't look at it that way. It's just how we build that future. And I think content ownership and the ethics of AI is something that we have to take care, that we have to attend to and be very careful about. Thank you.
Thank you very much. I think we'll have our last question for today. So Brandon, do you want to unmute yourself and ask the question? Thank you.
Okay, thank you. So hi, I'm Brandon. My question is about AGI. So with DeepMind, we learned that kind of this deep learning brute force technique is maybe too computationally expensive. So what are the kind of techniques that software engineers and like people researching AI are kind of exploring? Because like we can't just tell the AI to just learn everything by itself, right? Or are there some algorithms that are being researched, or like what is the current roadblock right now in research?
I can maybe just take a stab at this question. And of course, everyone else should feel free to chime in if they have different answers. I don't think the impression is definitely not that you can't use deep learning based methods to solve problems. There are a lot of meaningful problems that are being solved in production today at a lot of companies that do use deep learning and neural network systems, many of which are very data hungry. You can also actually do with the emergence of, I mean, not emergence, but like one of the more recent advances of the last five so years, and in the NLP context, even sooner than that, transfer learning has become like quite a big deal, where you have this system where you can one time train a model on a tremendous amount of data. I mean, GPT-3 is one example, but the GPTs in general, transformers as a general modeling class, BERT, if you've heard of these names, a lot of these systems are trained one time on a tremendous amount of data, and then you can just adapt them to a task that you're interested in via smaller data sets. And so you essentially pay the cost once of very expensive training, and then gradually you can adopt it to as many tasks as you can possibly think of if you have the right data for it. So these techniques have actually been used very extensively in a lot of different use cases, production and certainly in research. And there it's not as computationally intensive. I mean, some of the models can still be computationally intensive, but it's certainly not at the level of like a GPT-3, where I think they had to pay like millions of dollars basically in training costs for the hardware they used. I think that one of the bottlenecks still ends up becoming, how do you get the right data to train the models for the systems that you're trying to build? And I think that data still is the biggest issue, I think, most of the time, at least in my experience. Getting the right data, making sure it's labeled with the labels that you need, making sure they're high quality labels. We have so much data, but we maybe don't have the data in the right format that we need to solve our problems. And so I think that that is something that more often than not, a new task begins with just an understanding of like, what kind of a data do I need to curate to solve the problems that I'm interested in? And then you start labeling, and then you have to fix the labels, and then once you have the model, once you have that set up, everything else is pretty commodity. I mean, a lot of the models that we have today, given the right XY pairings, you can actually do a pretty reasonable job at getting good performance for a lot of problems. So I think that data is something that is still problematic, getting the right data, and cost, depending on what you're working on, may not be, these deep learning systems don't have to be as scary as they might sound. Though, yeah, a GPT-3 type system, that system is basically out of reach, except for, I would say, like a handful of companies that can afford to pay that kind of money to train it.
Okay, thank you.
So thank you very much for coming. So I think that's it for all the questions. I will go back to Aditash. Right.
Yes, of course. So I think it would be great if everyone could sort of join us in a virtual round of applause for all the panelists, for coming out and speaking to us from basically all over the country, and sharing, their wonderful thoughts on a lot of these topics. And also as well to Professor Mandt for, being here and introducing the panel and sharing his thoughts as well along the way. So I'll let the reactions die down in a second. Right, okay, so with that, I would like to wrap it up and just say, thank you everyone for coming, and have a great rest of your night. The recording for this will be uploaded to our YouTube channel. So if you ever want to go through this again and see what was asked, or just revisit any of the topics, it'll be up there. I've also saved a bunch of the links from the chat regarding what was sent out, and that'll be in our newsletter. So look forward to all of that, and have a great rest of your evening or night, everyone.
Thank you. Thanks for having us.
Thank you. Goodbye.
Thank you. Bye.
Bye.
Thank you.
I have a quick question, Aditesh.
Yeah.
Yeah, so well, this is my first meeting here for in the AI club, and I would love to join as a member. So is there a registration process maybe, or is it anybody can, is it just open to for attendance all the time?
Yeah, so we are open to attendance. Anyone can come to any meeting if they want. We don't really have any restrictions like any of that. I would recommend you to check out our link tree that has all of our things, but the most important things on there are our Discord and our newsletter, right?
Okay.
So our Discord is obviously where we have discussions on various topics, and then our newsletter is where we send out all the announcements for each week. And just to give a brief overview, what that's going to look like is that newsletter usually goes out sometime on like Friday, Saturday-ish, and it has the information for the week. Our meetings are Mondays at 6 p.m. and that's like a regular meeting. So this will usually be a workshop, or this panel, or maybe even something related to our project program, which is something we try to run, is where people can get together into projects and we'll fund their projects as they work on them. So those are all happen on Monday. Then on Wednesday, we have a separate meeting. It's also at 6 p.m., same link. And that one's fully virtual as opposed to the Monday one, which is hybrid usually. But the Wednesday one is a paper circle. So we just go and discuss research papers for like an hour every Wednesday. And the paper of the week is released within the newsletter. So yeah, all of that is on there. Make sure you sign up for the newsletter, and also shoot us an email at aiclub@uci.edu, and I can forward you this week's newsletter in case you want any of the information from this week.
Okay, thanks so much. Where can I find the newsletters?
Do you see
it will be on
chat?
the Discord, right?
No, do you see the chat? It says link.
Yeah, the link tree. Okay.
Okay, yeah. So if you see it, there's newsletter and it says Discord. So both of them are on there.
All right. Thank you so much.
Yep. Connie, Li Qian, anything? You good? No questions? If not, I'm going to just end the meeting. All right. See y'all, guys.